You guys can talk now.
Okay,
Excellent. I guess we're live.
I think we are. Hey, everybody. Thanks for joining the community forum. Michael, what's new in Europe today? Am I still able to come over there with my US dollars and live like a king against the euro, or what?
I wouldn't say like a king, but if you sell your California property, you can come definitely to Europe, live like a king. But I'm fortunate enough that I live in Portugal, and we don't have the pipeline that connects us to the European gas network. So my energy bills are still quite manageable, since Portugal, guess what, this runs on renewable energy during the summer. So
that's why renewables are cool. That's
exactly.
Excellent. Well, thanks to everybody for joining. Again, I'm Jesse. I'm the CEO of EnergyWeb, joined by Michael, our lead economist on staff, and we're really excited to have this conversation about the consortia relay chain. Just a few housekeeping notes, and we'll jump into the second slide here. This is our first kind of format using these tools in terms of technology, so bear with us if we have any little hiccups or anything like that. We do have Daniel in the background from our team, so if you hear any other clattering on the keyboard or anything else, that's him. And yeah, we'll go ahead and jump in on this slide here. So look, the focus of today's forum, just to kick off, is that it's really about technology and token economics for EnergyWeb. And specifically, we're really not going to be discussing the detail of EnergyWeb solutions or really how they solve challenges in energy markets. So if you're a grid operator and you're listening to this conversation, or you're a distributed energy resource company or renewable energy company, we do want to work with you. We want to have those conversations. And if you're interested in learning more, please do get in touch with us. But again, this conversation that Michael and I are about to have is really focused specifically in terms of EnergyWeb technology and the token economics that are going on behind the scenes of that technology. Yeah. And on this next slide here, just a couple of other caveats up front before we really jump into the conversation today. We are going to be assuming some background knowledge on a couple of high-level concepts. So the first one is the EnergyWeb chain. So this is the blockchain that most activity takes place on in our ecosystem today. A second piece is the EnergyWeb Decentralized Operating System. So that's EnergyWeb's open source stack of standards and technology that we use to build solutions with everybody in our community. And then the last thing is the fact that we at EnergyWeb and our community use this thing called self-sovereign identity. So for example, things like decentralized identifiers and verifiable credentials. We are going to be talking about those concepts. The last thing is we're not going to be discussing anything having to do with EWT price or markets. So, Michael, did I miss anything there on caveats before we jump in?
No, I think we covered.
All right, cool. And if you do have questions, we have some champions from EnergyWeb and Saoyem, our community moderator. Hit them with questions because we're not going to be doing a live Q&A during this session, and we can take all those questions and make sure we answer them after the fact.
However, we greatly appreciate all the questions that we got asked prior to this session, and I got a whole bunch of really cool questions off Twitter from the community, and we structured those slides and the session in a way to answer as many of these questions as possible. But let's say if after listening to this presentation there are more questions or something else needs clarity, then as always, I mean, hit up our channels, and we're going to discuss it later.
Excellent. So on that point, on the fourth slide here, in response to questions we got from the community, and this is a mashup of questions we got from EnergyWeb members, questions we got from folks at large. These are the 4 questions we're hoping to answer during this session. So the first one, which we'll jump in on now, is how is the EnergyWeb Decentralized Operating System evolving? The second one we'll focus on is what is this thing, the EnergyWeb Consortia Relay Chain? Why are we even building it? Third, what are the token economics going on behind the scenes with the Consortia Relay Chain? And then fourth, just generally speaking, how can EWT holders actually get involved with the Consortia Relay Chain? So that's the fourth question. So let's go ahead and jump in. And I'm going to take the reins on this first part, just talking a little bit about, on slide 5, the EnergyWeb Decentralized Operating System. So Daniel, if you could make sure we're on the slide 5 here. Cool. So look, really simply, we've been at this for a while. I've been working on the Energy Web project since about 2016, and we had a lot of assumptions when we started bringing this thing called the Energy Web Decentralized Operating System to market. And those assumptions, I mean, we're now here in 2022, almost in 2023. Those assumptions have evolved significantly. So first, we assumed that our technology could unlock business value for enterprise. That was a basic assumption and the reason we started Energy Web in the first place. And I'd say on that assumption, we're looking good. That's why there's a green check there. We have identified with our community 3 different business cases that we think are really compelling for businesses to actually use our technology stack. And I'm not going to go into detail on them here, but folks have probably heard about our different green proof solutions that we're applying to different supply chains, including Bitcoin, enterprise asset management solutions having to do with identity and Internet of Things devices, and then these enterprise data exchange solutions, specifically the ones underpinning our work in Australia.
Yeah,
2 other assumptions we have.
Maybe if I can add, by, let's say, positively verifying this assumption is not just that we talked to somebody and they said, yeah, sounds good. It's actually that we have a ton of proof of concept and a ton of MVP projects that were successfully completed. And on several fronts, we are moving to the production phase on those solutions, which I think it's a big deal, right? Because we are a truly Web3 decentralized organization, it's a nonprofit that is actually moving into production some of the solutions with the biggest enterprises in the energy space right now.
Indeed. And I mean, just myself speaking as someone who lives in California, we avoided blackouts on the grid 2 weeks ago during a heat wave because customers responded to programs like the Flex Alert solution that Energy Web supported the California Independent System Operator rolling out. So again, I think the business case for working with Energy Web is just getting better. These other 2 assumptions, though, I would say, Michael, we've learned some things about. So the second one here, we originally assumed that enterprises in our ecosystem would basically use these different Legos or building blocks and kind of construct their own solutions. And I'd say what we've learned there is that some companies in our ecosystem will do that. They have teams within their companies that can build solutions using the decentralized operating system. However, speaking frankly, most will not. Most of the companies that we've been in conversation with for the past 18 months, they actually want easy access to the business value that our technology unlocks, but they don't have the capabilities to build things on their own. So that's an assumption that we're learning a lot about. And the last one on here.
This is pretty much in line with lessons learned from the adoption of open source software in general. So open source software solutions, let's say, skyrocketed in popularity after the cloud infrastructure became readily available for enterprises, where people can, let's say, not just access stuff, but consume it in a way that is enterprise friendly.
Definitely. And look, the last point here is very similar. Our assumption kind of drew forth from this logic, which was, okay, in order to maximize adoption of Energy Web, we need to just focus on building out this thing called the utility layer of the decentralized operating system. Well, really what we've learned is just building these standalone building blocks is not enough. Just like just bringing forth cloud infrastructure, it doesn't mean that companies are just going to go out there and get it completely on their own, especially at the beginning of that industry. The other thing we've learned is that it's very challenging for corporates to hold crypto, including EWT, and specifically private key management is a major barrier to enterprise adoption of Web3 in general.
Well, yeah, and add to that there are no procurement processes to buy something from a nebulous decentralized blockchain cloud. And also the accounting process of, let's say, pricing those assets on the balance sheet, that's a nightmare. And a lot of companies just won't do it.
Yes. So look, on the next slide, I think the point here for the rest of the community before we go on and start talking about the consortia relay chain is that our technology stack is just evolving with our learnings. So now the decentralized operating system, basically we're bundling those components, which are shown on the left of this slide, into these standalone solutions that make it really easy for businesses in our ecosystem to access value. And the 3 different solutions I'm showing on the right here, again, we talked about them briefly before, our asset management solution, our data exchange solution, and then a variety of green proof solutions, which are themselves composites of the different building blocks of the decentralized operating system. So that's what we're moving towards. And on that point, look, before we jump in on the consortia relay chain, just on the next slide here, our team's been very busy. So basically, these different solutions are leveraging a number of new building blocks of the Energy Web decentralized operating system. They're shown in a brief snapshot of the slide here. We're not going to go into detail on all of them, but we're going to spend most of this conversation on the consortia relay chain. But there's also a number of new technologies that we are already using that are happening in the background. We have this thing called the Decentralized Data Hub, which is now how we're sharing messages and data between enterprises and our community. Decentralized logic execution. We did a member event on that recently, and we're going to be publishing it soon for the public. Very powerful tool using blockchains to perform specific business logic. And then also continued work on green proofs and a data storage configuration tool. So a lot of new building blocks of the decentralized operating system coming to light, not just the consortia relay chain.
Yeah, and maybe what's also important to understand from this slide is that the current Energy Web chain is not going anywhere. So all the building blocks that have been developed so far are here to stay, and there's a lot of very interesting activity going on, a lot of interesting projects on the current Energy Web chain. And so this is not a migration project. This is building something new in addition in order to facilitate our mission.
Exactly. And let's jump right in on that on this next point. So slide 8 here, just saying, let's dig in. So what is this thing called the consortia relay chain? Michael's been talking about it. I've been talking about it. Walter on our team's been talking about it. We've hosted several sessions. Basically, the update today is we just want to get more specific on why we're building it, the implications for our community, and then basically how to get involved. So this chapter, we're going to just focus on the why we're building this. So on slide 9 here, here, basically, as folks on this line likely know, most of these Energy Web solutions are built around self-sovereign identity. They're built around decentralized identifiers. And from our perspective, in order to make decentralized identifiers truly enterprise grade, and when I say enterprise grade, that means easy for businesses to actually adopt and trust this technology, our team's found 2 challenges that have to be overcome. Put another way, we're really excited for the switchboard release that just came out, and we hope people out there in the community are using it. But that's not enough. We have to keep building on the momentum that we've started with switchboard to make DIDs usable by businesses. So the first challenge we got to overcome has to do with the way that decentralized identifiers are resolved. And so really briefly what that means is that for anyone that's experimented with the DID, and you can see a really simple example on this slide, they include a identifier, but then they also include some documents. And those documents have information that specify what needs to be true in order for you as a business or a user to trust and communicate with that identity. And then there's this thing called resolution, which is the process of just linking those identifiers with those documents. So here's the thing today, and I'm not an expert on this, so I'm learning alongside our team who are experts on this. And so this was new for me. There are over 50 methods for that thing called resolution, which is linking those identities and the credentials associated with them. And because there's those 50 methods, that makes SSI really difficult. That makes self-sovereign identity really difficult for enterprises to adopt. And what we need is a solution that make it so that DIDs can be anchored and resolved using any of those 50 plus methods. And we need a way for those credentials to be stored and presented, everywhere. So that's the first point we're trying to resolve around. And Daniel, just real quick, if you can flip to slide 10 here, there's a visual for the community to try and just explain this in a slightly different way. So top right of this slide, Energy Web is one of those 50 plus methods. So we're using a method to resolve identities that are stored on the Energy Web chain in order to make them usable. But just look around. Microsoft now just announced their approach to using DIDs. They have their own method. We hypothesize that Google has their own method because they have a Web3 team. And then God knows how many other methods. So we'd have to believe that we can convince the entire world to use one method for resolving identities, which, speaking frankly, makes zero sense. Or we can create something that makes all of those different methods interoperable. So this is the first thing we're trying to solve with the consortia relay chain, is unlocking mass interoperability for all of these different approaches to using decentralized identifiers. That's the first piece. So if we flip to slide 11 here, and Michael, you should chip in after I walk through the first slide, because this is a little bit your baby too. On slide 11, so basically there's a second challenge that we've identified beyond the resolution thing, and that's all about cybersecurity. So basically, as folks on this line likely to know, and actually Michael wrote a great piece on this linked at the bottom of the slide if you want to see some more information. Something like 80% of cybersecurity attacks in recent history are actually identity-based. And put simply, that means that bad actors will present either a stolen or falsified credential to some form of a verification service. And most of those verification services, this is typically they're centralized. So you might have an IT administrator or a business unit within or an operational unit within a company that performs that service.
Yeah, or it can be a server even behind the firewall, but it's still just one server that performs the service. Because, interestingly, the service itself is not computationally intense, because it's just verifying signatures, and it's a binary outcome. It's either correct or incorrect. But if I'm an attacker, I can get incredible benefit from hacking into this identity verification service and then presenting my falsified credential, and then, let's say, forcing the service to give me an okay on that. And if it's just one server that I can hack and the payout is large enough, eventually somebody's going to do it. Right?
Yeah, and so this is really the big point. Just because, and I would really encourage the community to pick up on this, not just on EnergyWeb as a crypto project, but others, just the act of using DIDs doesn't do much in terms of cybersecurity. Like, that's something that I've recently learned. Pairing DIDs with a more robust method of authorizing credentials associated with them, that's how you start getting some real cybersecurity benefits. And this is what we're looking at doing with the consortia relay chain. So Daniel, if you can go to slide 12 here, we're trying to show this just a little bit visually. So generally speaking, this is just a way that you could think about presenting credentials. So basically in this example, starting from the bottom, moving to the top, you got a user, could be a device, could be a person, could be an organization. They would present a verifiable credential to some sort of a service that verifies whether or not that credential is valid. If that purple box, the VC service verification, gives the thumbs up and says that that credential is valid, typically an access token is passed back to the user, and then that user can use that access token to access a bunch of different infrastructure, right? What we're looking at doing with the EnergyWeb Consortia relay chain is looking within that purple box in the bottom right and decentralizing it, and basically creating an environment where multiple organizations, multiple servers are all checking the validity of that verifiable credential and how it was presented.
Yeah,
Did I get that right, Michael?
Exactly, because if we have a relatively easy deterministic binary outcome of a certain computational function, and this pretty much sounds like establishing a consensus in a decentralized network, right? So we thought, yeah, we've heard this before. So if we're going to have, instead of a single server, a network of nodes that are providing the service, we just need to provide some sort of, let's say, accurate and high level of trust into those nodes. And that's what we've been designing.
Indeed. So if we could go down to slide 13 here, this is why we're really excited to present something to the community. So look, we're trying to solve both of these issues. So the identity resolution piece and the fact that most credential verification is centralized today. We want to solve both of these challenges with what we are now calling EnergyWeb X.
Excellent, like over here.
Just like the shirt, indeed, indeed. So formerly known as the consortia relay chain, we're going to be using on a forward basis. So from here forward, when we talk about consortia relay chain, we are talking about EnergyWeb X. And this is the new blockchain that we are going to start spinning up within the community to solve both of these challenges. And the thing to take home on the right is that basically all of these solutions that we use, so asset management, data exchange, green proofs, they're going to be leveraging some of the value that EnergyWeb X can create because it solves both of these challenges. And so on slide 14, again, just to recap what we were talking about here, EnergyWeb X is designed to make self-sovereign identity broadly interoperable and enterprise friendly. So the work that validators on X are going to be performing is that work of resolving all of these different 50+ methods to establishing a DID, right? So this means we can actually work with any company using any method to establish decentralized identifiers versus only using something on the energy web chain, which is incredibly powerful for us to be able to do that. And second, X is also going to be offering a tool to the community to decentralize that process of credential verification. So basically, if a user wants to further bolster the cybersecurity of a solution, they can rely on validators on X to verify and vote on whether or not credentials presented to them are valid, which is a different architecture than that centralized credential verification approach that exists today. Now, the last thing I want to talk about here before we start digging in on tokenomics, and I pass it over to you, Michael, if we go to the next slide, look, Michael already mentioned this, is that X is meant to complement and not replace the energy web chain. Yep. So just to be really clear, and Michael, you're going to talk about, I believe, how we're actually using both blockchains in tandem to pull this off. But basically, on X, there's a couple things that'll be happening. So that universal identity resolution service, that's going to be happening on X. That process of tapping this decentralized credential verification tool, that's going to be happening on X. And furthermore, we didn't go into it today, but as an energy geek, I can't help but mention it. There's this new tool built called Decentralized Logic Execution. We'll be doing some more marketing and education on it. That's also going to be happening on X. Yep. But we're still going to be using energy web chain for most of our solutions. And it's still going to be there, and all of the activity currently happening on energy web chain can continue. So from our perspective, energy web chain, EWT accounts and balances, that's where all of that's going to be tracked. Energy web token staking is actually going to happen on energy web chain. And again, the energy web chain is this energy sector specific virtual machine that anybody can build upon. Yep.
Yeah, and let's say we're leveraging on the fact that energy web token already has some economic value and it's already well established within the exchange ecosystem, and there is some liquidity, which all is, let's say, prerequisite to efficient staking mechanism. So this is why energy web chain is not going anywhere.
Exactly. Well, Michael, let's flip it over to you a bit. So, what are energy web X's token economics? So how is this whole thing going to work if we're really using two different blockchains? Like you just said, value creation is still focused on energy web token, not some new token. What are we looking at here?
Okay, so looking at the next slide, 17. First, let's talk in broad strokes about the design principles for the EWX token model. So we need to have something that is simple and palatable for enterprises. So we need to design our ecosystem in a way that fits into the procurement process of an enterprise and not expect enterprises to, let's say, mold their procurement processes to accommodate us, right? And second, we definitely want to anchor the value of the whole ecosystem and our tokens in real-world cash flows. So we are really, a firm believer in creating first a sustainable business that solves the real problems that people pay for, and then translating it into the token and blockchain ecosystem. Then, of course, we knew that we already have this asset that has its own economic value, energy web token. So we need to build on top of that and add to it, not trying to replace anything or abandon it. And of course, the predominant, let's say, technical objective for all of these exercises was to increase the overall cybersecurity of all energy web solutions. So, I mean, if you're going to go to the next slide, we can start talking about the details. So let's start with the cybersecurity part of things and staking and validators. So what we're going to do is combine the best practices learned using the proof of authority which basically means that validators are known, they're identified, they're public, and also they have a high degree of competence in what they're doing. This is something that is absolutely required for any serious enterprise to use any blockchain solutions. And then we're also going to take what's the best in proof of stake consensus mechanism, which essentially is staking. So, we are going to require validators on the new Energy Web X chain to have both. So have the authority, and we're going to validate it by checking their verifiable credentials that they're going to earn. That they will have to be KYC, they will have to have high degree of knowledge and some certification with regard to IT cybersecurity. But let's say, last but not least, let's say for me, it's one of the most important prerequisites is staking Energy Web tokens. And what it means is that behind every single transaction, every single identity resolution, every single verification of identity documents, there will be this economic security of the entire ecosystem. So what's going to happen is that nodes that want to participate in this ecosystem will put their Energy Web tokens at stake. And it means that in case of bad behavior or some, let's say, malpractice or malfunction, these tokens can be slashed. And this will, let's say, keep everybody in check and make sure that users can have a very, very granular control over the level of security and speed of the transactions. So, what we are looking at is allowing users to define, for example, how many validators need to approve a verifiable credential in order it's going to get accepted. Right? It can be 1, 3 for low volume transactions, and there's 100% consensus for everybody else. Right?
Got it.
And,
so to play, so if I could interrupt just to play back and make sure I'm understanding it. So the idea here is that individuals, businesses, and these could be existing Energy Web member organizations, or they could be new companies that are interested in becoming validators on X. Basically, any of those kinds of organizations would be eligible to become a validator on X if they meet a staking threshold, and that staking threshold is denominated in EWT. If they pass basically a cybersecurity check, so they have to present something in terms of they know what they're doing on the cybersecurity piece. And that I see another bullet on here in that those validators can also accept tokens from patrons in order to hit that threshold.
Yes, that is accurate. So we don't have the specific number to share what's going to be the required stake, but it's going to be high. There will be a lot of zeros in terms of the dollar value. There will be a lot of zeros because we really want to make sure that the economic security tied to this whole infrastructure is really high. And this is why we expect either enterprises to come in that want to hold a lot of Energy Web token on their balance sheet. This is absolutely fine with us. But we also invite, let's say, startups or smaller companies that then will be allowed to open the staking pools to patrons, and then patrons will be able to help them reach the required threshold of stake.
Got it.
And maybe last thing before we move to the next slide, the staking itself will happen on Energy Web chain. We don't want to create any, let's say, problems with bridging tokens. We don't want any of that. Staking will be, let's say, natively happening on Energy Web chain, on the current chain, in native Energy Web token. And this will, let's say, passed on to the let's say, eligibility criteria for validating on X, independently of the chain. So.
Understood.
Yeah. And now let's look at the other side of the equation. So we mentioned that enterprises really don't like crypto as clients. So what we're going to do, we're going to have a setup where enterprises will be able to buy and consume energy web solutions just like any other cloud service, which basically there will be a price. The price will be either fixed or like a subscription fee, or it's going to be a value-based pricing or a consumption-based pricing. But it's definitely going to be denominated in fiat. Enterprises will receive an invoice from a valid, let's say, incorporated legal entity, and then they're going to pay in fiat. And then what's going to happen, let's say, on the blockchain side of things. So this is the, let's say, the lower bar on the slide, and then it says fiat, and there's this arrow, and this says network charges converted to EWX. So EWX is the native token of the Energy WebX chain, but it's going to be a stable coin. So it's going to be 100% backed by fiat deposits that are paid by enterprises. So the value is always going to be one-to-one to whichever fiat currency we're going to be operating. And tokens will be only released in circulation when there's a corresponding fiat payment coming from the client. Which makes it very transparent and user-friendly because, let's say, on one hand, anybody can look at the circulating supply of EWX and know what is the value of economic activity on this network. On the user or even development end, we don't have to figure out how much gas is going to cost me. Because if I have a price per transaction expressed in EWX tokens, I know immediately how much is it in dollars or euros.
Right. So before you go on to the next step, which I think is the top part of this chart, basically talking about this relationship between EWX and EWT. Let me just make sure I've got it to this point so far, because I think it's pretty simple what you're describing. So users of Energy WebX, right, which could be enterprises or could even be individuals, they're going to have to pay these charges, which I think behind the scenes we've started calling network charges. But that's basically just a fee sheet that's going to be denominated in EWX for different prices for using Energy WebX in different ways. And for some companies that aren't interacting directly with Energy WebX, just like you said, they're going to get an invoice for using some Energy Web solution. But then for others, they'll be able to just pay those fees directly. And the way that happens is fiat money comes in. That fiat money basically prints out a stable coin, Energy WebX, that's 100% fiat backed. So that's how we bring, again, real world value from businesses using this technology we make it digital.
Absolutely. Yeah, 100%. And I'm really happy that you mentioned that we have this added layer of convenience for enterprises where there are invoices and fiat payments, but this is going to be a permissionless blockchain. So any developer can go in, and everybody who's, let's say, crypto savvy can go and interact with this blockchain as with any other blockchain. The only difference is that the native token is going to happen to be a stablecoin. That's it.
Yeah.
So let's say what happens next with the network charges, right? We're going to have let's say, two types of services performed by the validators of the network. There will be those specific IT functions that's going to be performed, like propagating blocks, posting transactions on the blockchain, resolving identities, all of this stuff. And they are not computationally intense. Right? On the other hand, all those transactions require somebody running physical infrastructure and consuming physical resources. So there has to be a server or a data center somewhere that actually does that, people who maintain it. And what we want is we want to give our validators an ability to cover those operating expenses with probably a modest margin by paying them directly in EWX for those particular services. So the lesser part of all those network charges that are collected, they'll be paid to all the validators for the IT services and infrastructure they provide to the ecosystem. Let's say, but we believe that the majority of the value generated by the setup actually comes from this economic security that is provided to every single solution that operates on this chain. And this is why we believe that the vast majority of all those network charges should be paid for actually providing this network security. And how we're going to do it? We're basically going to take this big chunk of cash flows, and we're going to buy Energy Web token from the market, and then we're going to add those Energy Web tokens to people who already stake on Energy WebX validators. So with every single transaction, with every single dollar that is flowing through the ecosystem, we're going to be increasing the economic security of this whole network, basically increasing the value proposition of what we have to offer.
Got it. So just to replay one more time, and I think on the next slide, you're going to talk through it.
Yeah.
But just so, again, looking at the transaction fees coming in, so we've got these network charges accruing in this pot of value. A minority of those charges are basically going to be paid directly to validators on X who are performing this work. And that's basically meant to cover the operating costs of running that physical infrastructure. But then the majority of that value that's coming in from the real world, we're basically trying to use it to bolster the cybersecurity of not just Energy Web X, but every single identity and solution connected to it. And the way that we do that is take that value and basically bring more tokens from the open market onto the network by purchasing them and staking them against existing stakes.
Yes. And the logic is very simple. Let's say at some point in time, the total economic security of the network is worth $100 million because this is the value of the stake. So it costs an attacker at least $100 million to perform a hack. If over the years we're going to build up this the total economic value to 200, 500 million, then it's going to be that much more difficult or expensive for anybody to hack any of those solutions.
Understood.
So,
okay.
Yeah. So if we're going to move to slide number 20, I know that venture capital is like talking about flywheels. So we have a flywheel over here, and we're going to start at the top with the strong business case. So everything, let's say that you already mentioned, let's say the desire from the industry is there. Now we are just repackaging in a way that is easily consumable by our clients, right? So more adoption is going to follow, and this will generate a situation where there are more network charges, because there is a one-to-one relationship between the economic activity and the revenue that is generated by the solutions and the value that is flowing through the network, right? So the more economic activity, then the more impact it has on EWX token and Energy Web token, obviously. And let's say the bigger the impact is definitely going to have on Energy Web token, because EWX going to remain a stable coin. So more stake for the whole network, which basically means more economic security, more cyber security, which again, this makes our business case even stronger. So the way it is designed right now, at any given point in time, it is actually better for any outside organization to join our ecosystem and to participate than stay outside of it.
A nice flywheel. I think a VC would be impressed. Yeah. Cool. Excellent. Well, look, before we jump in the last chapter here, just to call out to the community, Michael and I just will talk through quite a bit of detail. And really the two big points here are just trying to help explain why are these different services interesting that Energy WebX is going to be delivering, and then how are we basically creating a mechanism whereby when users access those services, it's reflected in this entire kind of network effect that Michael's talking about. hit us with questions. We're going to be putting out more documentation, more different explainers to help everybody understand this. But these are the two key concepts that we think are really critical to understanding what this Energy Web X blockchain is all about. So hit us with questions if there's specific pieces of the puzzle that we can do better job of explaining. So last chapter here, just on slide 21, is basically what's next. So how can EWT holders get involved with the consortium relay chain, which again, Energy Web X. So that's how we're going to be referring to it on a forward basis. One thing that's really exciting on slide 22, and it should be obvious to the audience here, is that now Energy Web token holders have a crucial a crucial role to play in the evolution of Energy Web technology, and specifically, every Energy Web token that is staked will, in the near future, have a direct cybersecurity benefit for every single solution in our ecosystem, which we currently don't have, right? So this is what we're moving towards. And we could envision some hashtag EWT for climate Twitter campaigns popping up here. And the point is that the more that Energy Web tokens are consistently staked, the more secure every solution and identity is in our ecosystem. And this is exactly why the existing staking pools, the snapshot mechanism, that's why it's out there, because we're trying to create an environment where more and more people are staking tokens in order to increase the security of all these different solutions. So in the coming months, you should be able to think about staking EWT in new pools focused on helping to get Energy Web X off the ground, and indicating support for different validators by acting as their patron, right? So that's what I'd expect in the next couple of months. And then look on slide 23, just to preempt some of the questions that are out there. A number of design parameters are still being finalized here. So what are those staking thresholds? What are the specific verifiable credentials having to do with cybersecurity? Still figuring that out. Pricing. What is that fee sheet going to be to access the different services that the Energy Web X blockchain is providing? Identity resolution, verifying verifiable credentials in a decentralized way. That's still under design. Award schedule. So what percentage of those network charges are going to go to validators on Energy Web X versus network security? And then the last thing, thinking about these different pools, what is the award schedule going to be? Those are still under discussion and in deep design phase. Yeah.
Yeah,
but anyway,
a lot of those questions will be determined by the technology, right? Because I mean, for us, just it's very easy to talk over slides. It's very high level, but we have a brilliant team that is actually trying to build the tech that does all those cool things, and there are just certain technology requirements that we need to, let's say, take into account. I mean, this is why it's taking us a while, not because we're lazy. It's just.
No, I mean, we're building something that doesn't exist in any of Web3. So both of these things here, the resolution service for DIDs, and then creating this way for verifiable credentials to be validated in a decentralized way. These things do not exist now. So our team has been very heads down trying to build these, and we're really excited to bring it to life. So I'll leave it there. Again, we look forward to your questions so that we can answer them in the next session. Michael, thank you for joining me. Daniel, thank you for orchestrating everything in the background. Community, thank you for all the great questions. Keep them coming. And we'll see you next time.
Yeah. Thanks, guys. Thanks. Bye-bye.